In this movie, I've gone gun turret crazy, and I want to demonstrate that craze by showing you vector projection as well as some other little things besides. So I have this scene open in front of me here, which you can find in the course companion files under Assets, Scenes, and Projection. So we have this very basic scene, and I'm going to press play on the toolbar to first of all demonstrate this in action, and then I'm going to show you how it was constructed. So I'm going to press play here on the toolbar. We have this turret here in the scene, this gun turret. So you can see this here. So we have a simple base, we have a spherical top, and we have what might be the cannon for this character. And we also have what might be the player, which is this green sphere over here. Now, of course, as I move this sphere around, this gun turret turns to face the sphere. Now, that is nothing new. We've seen that before. But now if I click on this sphere and I move it over here, notice that the gun turret starts to slide along to face the player character. But notice that there's this green line here. So we have a start point, which is the start point of the line, and we have this end point, which is the end point of the line. Now we can only see this simply because I have gizmos enabled here in the game tab, but the visibility is not the important thing. Notice that this line acts as a track on which this gun turret should follow. So for example, I could change the size and the shape of this track to say a diagonal. Let's just move the endpoint over here. And notice now as I move this turret, as I move the turret follows the player to look at it and to shoot it, but it always is constrained to this track here. And in fact, I can move the track about. And as I move it around, notice that this turret is always sliding and moving along this track only in order to keep the player in sight. Now, to achieve this, I'm using vector projection, and I want to go ahead and show you how this scene is constructed. Before I show you the vector projection part, I want to show you how I'm drawing this gizmo line. I'm simply creating an object, an empty object here called line, and notice that I have attached to it a script file called gizmo line, and if I double click the gizmo line file to open that inside MonoDevelop, you can see the code we have. We simply have two variables, line start and the other one, line end. And then we have the onDrawGizmos function in which I'm specifying the gizmo color of green, and I'm simply using the gizmos draw line function to draw a gizmo line between the start and the end points here. This just accounts for the drawing of the line in the viewport. So we have that gizmo line function. In addition to that, we have the tracking behavior. So this refers to the ability for this gun turret to slide along anywhere on this line to keep the target in view. So for example, if I move the player character over here, the gun turret will come to a stop on this line. So we have the start here. Now it's at the center of the line. But of course, if this line were extended into the distance, it would again track that player at quite a different place, but it still has that player directly in sight. So we can see this being achieved using vector projection. Down here, we have a script file called posproject. And if I select the turret base here, notice that the turret is a complex object. You can see that from the hierarchy panel. If I select the base here, we have the turret base. We then have another cylinder underneath, which represents the turret that actually turns to face the player. And underneath we have the cube, which represents the cannon section. But I'm going to go back to the turret base because when I select that object, you can see from the object inspector that it is the object to which the posproject script is attached. And it takes primarily three parameters: the target, the thing that it should look at, as well as the start and the end points of the line that define the track it should follow. Now, if I double click on the posproject script to open that inside MonoDevelop, you can see what's going on. In the awake function, I simply retrieve a reference to the transform component. But here in the update, again, here is where the magic happens. I'm calculating the normal. That is, I'm calculating the line that the gun turret should follow. So what I'm doing is I'm taking the end point of the line and I'm subtracting the start point of the line, and that gives me a vector that is pointing along that line. And then what I'm doing here is I'm taking the line start position. So I'm using this position to define the position of our target. So I'm taking the start of the line position and I'm using vector project. What I'm doing is I'm subtracting the target position from the place where we are standing. And when this is combined with the normal, what the vector project function will do is output a completely new position that is assigned to the position here. So again, I'm calculating a projection of that vector. I'm adding it to our start position. And what this whole calculation amounts to is the new position for our gun turret. Now down here we have the clamping going on. And what clamping does is this simply prevents the gun turret from leaving the track. So if I just minimize mono develop here, again, and I press play and I move our character along to somewhere like here, I've now extended beyond the end of that track. But notice that the gun turret hasn't continued to slide along here to follow me. It hasn't extended beyond the end point of that line. And similarly, when I move the player character on this side, again, it stops at the end point of the track. It continues to rotate to look at me, but in terms of its movement, it doesn't go beyond that track at all. And that is what is achieved by the clamping. So if I bring back the pos project script, you can see down here that I'm clamping the X, Y, and the Z position of that turret. Math.clamp. What that simply does is it takes our current position and it gives us a minimum position as well as a maximum position, and it makes sure that the X value that is given out, whatever value is given out, is between the minimum and the maximum range. And I'm doing that for each of the X, Y, and Z axes. And then I'm finally assigning the result to the transform.position value. So by using a combination of clamping in combination with vector projection, we can create a gun turret that tracks the player and keeps them in sight always.